Alrighty, what we have here is the little hot air setup. Got my Variac, the base finished printing, so that's it set on the base over there into those pins. You'll see it in the video later, because after this I'm going to show you how to design the base for this. But let's have a go do some reflowing with this. So the idea is that I've got hot air coming out of here at about 150 degrees C. Heat up our board over here, which I've soldered, got the components set on it, and I'm going to heat it, and then we're going to take a hot air wand over here and solder it. So let's see if we can get you zoomed in on the action. That's it, like so. So I'm going to turn on the fan. Fan's running off 5 volts. Okay. Now the Variac over here to the left, that's providing us with 175 volts AC. And I can bring in a thermometer and we can verify that. Now I'm going to turn on the heat and you'll hear the heat come up. Turn the microphone that way. So there you can hear the heat coming up. Zoom you out. There's our thermometer. Let's see what that temperature is. So the heat's coming up. This is a very nice way of preheating a PC board. So that's our temperature over there. Coming up very nicely. Tends to be concentrated more around the edge of the tube, I notice. That's certainly coming up. I feel my hand getting hot. That's getting quite nice and toasty there. Okay, let's set that aside. I'm going to fire up the hot air and get you zoomed in again. Let's see how much of a mess I make. Temperature. Let's set that to 350. I bet everything's vibrating, because there's a diaphragm pump in this hot air station and it vibrates and it's causing noise on the microphone. I do apologize for that. I actually think I need a bit more airflow there. I heard the safety click off. Anyhow, let's see how we get on with this. Got a problem over here. Yeah, and they're tombstoning. Yeah, this is not going well. This is why I moved away from doing this assembly with hot air. I'm just going to pick those components up off there. hot, 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 hot. Take the op amps off. Like so. And those resistors can stay. The ones that didn't tombstone. Okay. Leave that like that and run the hot air down. So that is it. Basically, turn off the power to the heater over here. You can hear it go quiet. Run the hot air down. The hot air reflowing for SMD stuff is very tricky. I've had more luck just going in with my jig over here. The board set in the jig. Okay, it's still a little hot. I just set the board in the jig and I hand solder these components with a fine tip on this jig. So is that cooled down yet? Yes, it is. So how I solder these, right, so how I solder these is I have this jig and put the components down on the flux and just solder the joints. That has worked for me. But you know, I thought I'd do this experiment with this device, making a base which takes this heater and seeing if I could use it as a preheater for soldering, and it might work as a preheater for rework, but for assembly, no, this is not working for me. I'm going to go back to my tried and trusted method, just hand soldering the stuff on. That has worked for me. I don't have to do rework, so it's easy to do. Don't have to do rework. All my boards test 100% first time, so failure rate is 0, which is important when doing manufacturing. And there we go, we learned something. I learned something, you learned something, and it was fun designing this. So after this, in the rest of the video, you're going to see me designing this. So there's a bit of 3D CAD design work coming up in the rest of the video, which is an interesting video. So stick around, because next I'm going to show you how I did this. Made it in PLA, designed it, the 3D printer made it, it took 6 hours, and it just pops in there like that. Kinda, because the switch is in the way. It did messing me around. There we go, just like that. So stick around, part 2 of the video is coming up. I'll see you there, and just enjoy the video. It's a long one, but it's an interesting one. Started off with the experiment, and you got to see what the outcome is. You know, you got to try something, otherwise you don't know if it's going to work, how it's going to work, what the outcome is going to be, you know. But you learned something, and you know something that you didn't know beforehand, so it's awesome. So right, off to the next part of the video. See you there. Ladies and gentlemen, what I have here today is the popcorn maker heater. What I'm going to do is this over here. It's going to sit on top like that, and of course I was not prepared, but never mind, I'll show you after causing an avalanche. what I'm going to do. This is going to be a preheater for surface mount PC board work. So got the stainless steel mesh, which I've folded over. It's going to sit on top, and the hot air comes in the bottom courtesy of this fan. There's a heater in here. The fan is going to run at constant speed. I'm going to adjust the temperature by controlling the energy input to the heater. So this board is just going to sit over here like this. I'm going to have a infrared barometer aimed at the board, which is going to report the temperature to some PC software, and from the PC software I can start the heating. Once this is up to temperature, the PC will ding and it will tell me that this is ready for reflow with the hot air gun. So I'll get this up to about 150 degrees with hot air, then bring in the hot air, flow the components, then hit stop on the PC on my SCADA software. The heating will turn off and the board will cool down while the fan keeps going. So that's this little project, but the first thing I need to do is make a base for it, because obviously it doesn't stand by itself. So it's got these two pegs on the bottom over there, which I'm going to use to set this down into a base, and of course we're going to 3D print the base. So what I need to do is design a base. So what we have over here is a caliper. So let's start off by measuring the diameter of this heater. 110, right? There you can see it. I've got a terrible webcam, but generally I use my cell phone for recording if it needs to be high quality. Okay, so the outer circle is going to be 110. So let's start with that. So over here, why don't I turn on my colored circle so that you can see what I'm doing. Oh, I don't have it installed. Let me show you how to do that. Now let's bring in the browser. Like so. Google. Mouse highlight by Catnip. What should become mouse highlight Microsoft Store. There we go. Here we go. Yeah, that's the one over there. So I'm going to download that one. Let's go over here. Clicky install. Here we go. Right, starting download. Right, so in the meantime, while that's happening, let's have a look at this. Let's measure the distance between those two pins. So that is probably a round number. I'll tell you what we can do. That's 7 millimeters in diameter, and the distance between them is 69. So, oh look, it's installed. Let's change that to a color that everybody can see. Let's change it to green. I've got an even better idea. Let's change it to blue. Is this going to happen? And then I'm just going to disable click highlight, and then we minimize that. Now you can see the blue dot. Okay, so we're going to need to do a bit of math, but let's start off with a circle. So I'm going to hit Z, zoom out a bit with the scroll wheel, hit C for circle, and we want 110. Here's our circle. Hit H for home view. Let's pull it up a bit by hitting P, and I'm going to make that 4 millimeters thick. Let's give it some rigidity, and then to make it pretty, let's radius that by 4 millimeters, so it's going to look nice. Always think about that when you're designing your stuff. Alright, now selected the top plane because we want to add our posts. Okay, so I've selected that plane. So we said that was 69. Now this post is 7, so half of that would be 3.5. 7, 3.5. Yeah. So let's draw a construction line which we can later delete. Come. L for line. We said 69. So let's go 35 each way, which is 70. Let's start in the center and go 35. Go here and go 35 here, and set line again 35. Right, now 70, so 70 apart. We want to, that was half a millimeter we added. So in other words, this point over here needs to be 4 millimeters away. So let's hit escape, zoom in, hit circle, and let's draw some posts. Let's start with the outer diameter. Now we know these are 7. Let's make it a nice, generous and strong post. It's going to clear everything around it. So let's go for 15 millimeters. Right, let's go to the next one. 1, 2, 3, 4 millimeters in. It's 15 millimeters. Now we hit E and we measure the distance between those two. Control. Right, 62. So we have done something wrong there. Oh yeah, I know what we did. We are 69 plus 7. Yeah, we're a little bit wrong there. So what we're gonna do that 15. We might have to move these a little bit, but that's okay. E, let's get them close to where they need to be. 68, and we want them 69 apart. Or did we say? I know we were wrong. It was supposed to be 62. Got to pay attention to what you're doing. Okay. So, let's go circle. 1, 2, 3, 4, 15. Delete that circle. S for select. Delete it. Right, 1, 2, 3, 4. Circle. 15. Right, now let's measure them again. .62. So that distance to there should be half of it. Yeah, 31. So that one and that one should be 31 as well. And we can also see it when we select it. It's 1 millimeter over from the 10 millimeter line, and the same here. Right, now we want to give them some length. So what I'm going to do, 15 is looking good there as well, like so. Right, so I'm going to P. Now before we do that, let's hit S. Let's get rid of our construction line. Then go back to P. And draw them up 15 millimeters. Let's gusset them a bit. How does 3 millimeters look? Beautiful. 3 millimeters. Now they need holes in the top of them for these posts to go into. So Z, circle. Now we know that these are 7, and we want them to slide in, so I've got to add half a millimeter, because the printer is going to make them a whole half a millimeter smaller. So circle 7. I want to give it just a little bit of clearance, 7.6. Same here, 7.6. Right, home view, pull, control, 15. And that's them made. Let's chamfer those a little bit. They don't need to be flat on top, like so. What else do we need to add? I think nothing. I don't really need to make this thing enclosed at the bottom. It needs to draw air in over there. But I'm tempted to do it. Very tempted. Because that'll just make it look decent. So I think let's do it. So let's take that radius away by clicking on it and hitting 0. Doesn't want to take it away. What we can do, I'll turn this thing upside down. I wonder if it'll let me pull. No. So I'm going to need to fix that by another means, which is very easy. We hit C. C on the same line, 110, pull 4 millimeters. Move escape, move, select the arrow, 135, then we select that line. It can actually stay there. Oh, it's made a mess. Let's get rid of that. That's not working. Let's try a different approach. Let's pull that up 15 millimeters. And then what I'm going to do is go here. Pull that down 4 millimeters. Okay, that's made it back into a solid. That looks rather nice. You know what I haven't done is taken into account the motor. Yeah, oops. How much do I need? About 20 millimeters. So what I'm going to need to do, then move all of that up. So I'm going to go M, and got those selected, hit the blue arrow and tell it to add 20 millimeters to that. Okay, starting to look more sensible now. So I suppose now that we're at this point, we should probably make a hole for the cable entry. Um, 10 millimeters should do. Control Y. Circle. Let me show you how to make a slot. 10. Let's go back to that view. Escape. Let's Try and select on that line. Okay, now I'm going to drag it through. Now that's it. So hitting Alt and pulling down change the direction that we wanted to make the slot in. So you start off with a hole, then you select the center over there, then you just select the direction you want to go in, and then you pull your slot down. Right, what else do we need? Let's make that look a little better, like so. Let's give it a bit more. I think I'm going to leave the bottom flat. Let's just fix this top surface over here. So that's decent, doesn't have a sharp edge. And yeah, let's fix this as well. Control, let's select all those edges. Let's go in by 1 millimeter. That's chamfered. Hit Control. That's chamfered. Nice. Starting to look half decent. So now, what is that height from the bottom to the top? Let's select that plane. 39 millimeters. So what is that going to do for us? That is going to come up to here. I'm tempted to give it a bit more height. So hit M for move. Come on. Suppose I can manually select them as well. Let's see what's it gonna do. Let's move it up another 4 millimeters. Okay, I'm happier with that. Just want to make sure that there's enough space for the motor. All the way around in depth. Okay, what else do we need to think about? Need to put that screw back, I see. why don't we to slot this back part on the hit S. Let's make a slot for air at the back. Circle 10 millimeters. I need to probably move that a little bit. Actually, Alt escape. Pull. No, that's not what I wanted, not sideways. There we go. Vertical. So now what does that look like? So I think what we need to do is move it so it aligns with the other one. So on at M, oh, we don't need to select that, we only need the top and the bottom. M, the green arrow, .5. Okay, now they're lined up. Now we can chamfer it. Need to pull, control, select your edges, 1 millimeter, rinse and repeat. Control, select them, 1 millimeter, H. How does that look? Okay, now it's symmetrical. I think I'm happy with that. So that's going to be the base for our heater. And it'll sit nicely like that. And our board that we're preheating is going to sit like that on top. It gets 3 op amps and 7 resistors. It's a simple little board. And then I have an I2C passive barometer, which I'll point at that. Connect to an Arduino, which will talk to my PC, where the control software for this will live. So this is going to be a handy dandy little PC board preheater. Could probably do more than one at a time on here. Looks like there's room for at least two. Very good. This is going to be nice. This is just some stainless steel mesh, some generic stuff. Cut it and folded the corners over. It was originally a long piece. It looked like that. Came out of a swamp cooler. I think it is stainless. It is quite hard, which is good. So we shouldn't have corrosion problems. So ideally one wants to look for stainless mesh. Even cutting up a basket intended for cooking in or something like that, or a sieve will do very nicely. So a source of this type of material shouldn't be too hard to find. And that's going to be that. I'm going to stick this in the 3D printer, get it to make it. So let's slice it. Mechanical sundry hottie preheater base, and then we want let's find it in File Explorer. Documents, mechanical sundry, H base STL, repair model. I wonder what the problems were. I didn't do the best job of designing this, so there's probably some errors in it. I don't see them. The slicer fussed about it, but said you want to repair the model. Yeah, whatever. As long as it comes out like this. Oh, there's an artifact over there. Let's see what it looks like. No raft. Let's see. Alright, slice preview. Layers. Yeah, it looks alright. I think it'll be fine. 6 hours. You won't see this today. But what I can do is start working on the electronics in the meantime. Because what the PC software will need to do for this is control an output on the Arduino, which pulls in a relay for the Variac, with which I'm going to work the heater. So I can start doing that type of wiring while this base is being made for me. Let's just lastly, one more time, verify that inner dimension 7.6. We were happy with the spacing. But we said needed to be 62. and that is the same over there. You can see it's 62. So I think the critical dimensions are okay, and I can go ahead and print this. So that's going to wrap this up. That is my new little project that I'm working on. This hot air preheater for PC boards, which is going to have some automation. And we've gone through the design of the base for the heater which came out of a popcorn maker, which is going to be the basis for our design here. Because I have used aluminium plate on top of a spiral for preheating, but I'd like to move away from that and try automating it, because I want to try a different type of technique with my soldering of these things, where I put flux, put solder, put the components down, then preheat this, and then with a hot air nozzle flow the components down into the solder. It's currently a hand solder them, but I've had an idea for doing it differently, which might be more effective. So I'm going to try that, and for that I need to preheat these PC boards on this thing like so. So that is the agenda. Right, so time to put this into the 3D printer. I think I'll make it black PLA. Get this made, and then we can carry on with the rest of the project. So this was a long video. For those who enjoy a longer video, thanks for being here, ladies and gentlemen. Take care, and I'll be seeing you next time with some kind of interesting stuff for an update. Take care, be well, cheers.